speeding bullet. More powerful than a locomotive. Able to leap tall buildings at a single bound. Look, up in the sky. It's a bird.
It's a plane.
It's Superman. Yes, it's Superman.
The Adventures of Superman was a TV show that was produced in the 1950s, but the very first appearance of Superman was in Action Comics #1 in June of 1938. In that comic book, he had powers very different from what you might see today. He was not nearly as strong and as fast as he is in today's comic books. In fact, in the comic book, in 1938, it says that he could jump an eighth of a mile or hurdle a 20-story building. So that's about 200 meters. Certainly no small feat, but not really flying. Well, I thought it'd be kind of interesting to do a kinematics problem with this and ask ourselves just how fast would Superman have to jump up so that he could actually get up to 200 meters. So I thought we'd work that problem together as a good example of a free fall problem. So we start with delta y would be equal to positive 200 meters because his final position is higher than his initial position. Of course, the acceleration due to gravity, we'll say negative 10 meters per second. His final velocity at the very highest point would be 0 meters per second. And the question is, what would his initial velocity be? And we don't have any time here, so the equation we would use, Vf squared equals Vi squared plus 2a delta y. So we have 0 squared equals Vi squared minus, well, let's see, 2 times 10 is negative 20 times 200. We end up with negative 4,000. So 4,000 is Vi squared. Vi is equal to 63.2 meters per second, which, by the way, is about 142 miles an hour. To put that in perspective, for a human being, a regular human being, to jump 1 meter off the ground, certainly no small feat, would require them to jump at about 10 miles an hour. So Superman can jump at about 142 miles an hour. You and I, if we're lucky, we can jump 10 miles an hour.